Okay, so today we'll be graphing exponential functions. So here is an example question. These are all exponentials, all slightly different. Now, they've asked us for equation of the asymptote and the axis intercepts. So the key features of an intercept of an exponential graph is the shape, asymptotes, and axis intercepts. These two are the most important because every exponential has a shape and has an asymptote. However, not all of them have a x-intercept. They will always have a y-intercept though, and that's when x equals 0 always exists, y equals 0 doesn't always exist. So quickly, we're going to go into what the shape looks like. There's a few different things that can happen. You can have y equals this. So if we had y is equal to 2 to the x, the 2 and x is positive, we can have the 2 be negative. We can have the 2 be positive and the x be negative. And we can have both of them being negative. It's a quick diagram of what they basically look like. So if they're both positive, they start small and grow exponentially, given the name. Now, you can add your axis intercepts later on, but this is the general shape, and there'll always be a horizontal asymptote. Now, if it's a negative, it'll look like this. It'll start off next to the asymptote, and then it will drastically change. Next is if the 2 is still positive, but the negative is on the x. It'll be, we call this growth, we call this decay, and decay is these negatives and growth is these positives. And you can imagine the sign in front of the 2, so not in front of the x, or it could be a constant, so y equals plus or minus 10 to the x. The 10 would be the constant. The positive or negative outside the constant flips it. So notice how it's almost identically just flipped. If that makes sense. So first thing is to dictate the shape. Which does it look like? This, like this, or like this, or look like that. Once you've done that, half the job is done. So let's take f. We'll just do a, for example. Graph f of x is equal to 2 to the x minus 4. Which shape would it be? It would be this one. So it looks something like this. It has an asymptote. Done. Now, next is to find the asymptote. The asymptote is the easiest part. So if, in this case, the asymptote is y equals negative 4. How do I know that? You can just read it off. So for example, here, the asymptote here is y is equal to 4. Y is equal to 4. Y is equal to negative 3. Y is equal to 3. And what they're doing is you can see how they're trying to trick you. They're shifting the 2. So it's the number that doesn't have an x to it. And what I mean by x is, it's a little blurry, but that x here. So in this case, the asymptote is y equals 60, not y equals -5. These two are attached. Anyways, so now the next part is to find your axis intercept. I would always start off subbing in x equals 0. So we end up with f of 0 equals 2 to the 0 minus 4. Now, obviously, 2 to the 0 is equal to 1 minus 4 equals -3. So we have 0 and -3. Now, if we had a scale, if -4 is here, -3 is around here. And this is where we can add in our axis. This is 0 and -3. And clearly we can see that there will be a x-intercept. There may not always, so we'll sub y equals 0 now, or f of x equals 0. 0 equals to the x minus 4, 4 equals to the x equals 2. Now, sometimes there isn't an x-intercept. For example, let's do this one. F of x is equal to 4 minus 2 to the x. What shape is it? Look at this, that, or this. We can see this is negative and this is positive, and it'll be this one. Oh, sorry, it'll be this one. So we know it's going to look like this. And our asymptote is y is equal to 4. So let's find the y-intercept. So f of 0, this basically says sub x equals 0. And that 4 minus 2 to the 0 equals 3. So 0 and 3. So if this is 4, 3, 2, 1, 0, you can almost imagine like a little scale. So this is around 3. And this is where the x-axis goes. If you imagine 4, 3, 2, 1, 0, this is where the y-axis goes. And this one, actually, it does have an x-intercept. We can just tell from the shape. So then f of x equals 0, 4 equals to the x equals 2 again. So it's 2 and 0. I want to see, I'll make one so that there is not one. So let's graph. F of x equals -4 minus 2 to the x. Shape, it's the same as last time. It's going to look like this. Now, asymptote. Who can tell me? Y equals -4. Now, sub x equals 0. We end up with -4 minus 2 to the 0 equals -4 minus 1 is -5. Now, since this is -4, -3, -2, -1, 0, this is where the axis intercepts. The axis will be. And clearly there will be no x-intercepts, and we are done. So have a go at the rest of these. All of the indices are positive here anyway, so you don't really have to worry about decay at the moment. But try get used to finding the asymptote and graphing just the shape. Now, I will say some of the questions, you might be given a grid or a pre-made grid. this is easy. You probably just want to do the asymptote first. So I will do a few examples instead of the shape. So if we have y is equal to 4 minus 2 to the x, we know the asymptote is y equals 4 immediately. And then the next thing you want to find is the y-intercept. And that will be x equals 0. So you get 4 minus 2 to the 0 equals 4 minus 1 equals 3. So 0 and 3. And then the shape next. And then clearly we can see it's going to look like this. Good. And then now we can tell there's going to be an x-intercept. We go y sub x y equals 0. 0 equals 4 minus 2 to the x. To the x equals 4. X equals 2. Okay. So this probably is the best way to do it. But if you're doing quick problem solving, it's probably best to learn both in order to get the foundation for the learning. But in an exam, you'd want to do this method. Now, since we have a lot of time on our hands preparing, we have the time to do both methods to wrap it over our head. Basically understanding how the shape, asymptotes, and axis intercepts work, and the conditions of what needs to occur in order to graph it. I will say this is probably a more efficient way. So if you want to stick with this one, this is fine. However, both work, and if you can do both, it means you have a solid grasp. So if you complete all these questions and you feel as if you did them well and pretty easily and handily with this method, try use the second method. You learn a lot more doing a method that's less efficient, to be honest, and that's good. Alrighty, thank you.